Hi all, hope you all are doing good. From today onwards, we are going to see a lecture series on the subject Design and Analysis of Algorithm. Please note down the course code. It is 19 ITB 201. B represents blender, so it is a blended course. So first unit is Introduction to Algorithms. Now we are going to say about the mathematical analysis of recursive algorithm. And recursive algorithm, we have first general plan for analyzing the time efficiency of recursive algorithms. What do you mean by recursive algorithm is the algorithm that calls in itself for further functioning of the program is called recursive algorithm. There are 5 steps in analyzing the time efficiency of recursive algorithm. The first step, we have to decide upon the parameter, that is input size. We have to analyze what is the input size given to that particular algorithm. The second step is we have to identify the basic operation. The third step is we have to find number of times the basic operation is going to execute. The fourth step is we have to set up a recurrence relation with an appropriate initial condition for the number of times the basic operation is executed. The fifth step is we have to solve the recurrence relation, or at least we have to ascertain the order of growth of its solution. Example we are going to see under recursive algorithm analysis as the towers of Hanoi. What do you mean by towers of Hanoi is we will be given with n discs of different sizes of 3 rods. Initially all the discs are in first rod, largest on the bottom and smallest on the top. The goal is to move all the discs to third rod with the help of second rod if essential. So the condition should be applied here is we have to move only one disk at a time. Condition 2 is place smaller disk on the larger disk. The smaller disk should be upper and the larger disk should be at the bottom. These are the two conditions of towers of Hanoi. So this is the setting up a recurrence relation. So make a note of it. We are using the B rod as an intermediate for moving rods. So for moving disks in A to C. So here the initial condition m of 1 which is equal to 1. If there only one disk, we can move to third disk with one move. So where m of 1 is equal to 1. Now we have to frame the equation, that is recurrence relation equation, where m of n is equal to m of n minus 1 plus 1 plus m of n minus 1 for n greater than 1. So now we are going to use backward substitution method to solve this recurrence relation. For backward substitution, we have to substitute n minus 1 in this first equation instead of n. So instead of n, here we are going to substitute n minus 1 and substitute this final equation in terms of m of n minus 1. So this substitution is called backward substitution. So after applying the backward substitution method, we will be arriving at the equation m of n is equal to 2 power I m of n minus I plus 2 power I minus 1 plus 2 power I minus 2 plus up to 2 power 2 plus 1. So we can rewrite this equation as 2 power I m of n minus I plus 2 power I minus 1. So here the initial condition is n is equal to 1. So I is equal to upper bound minus lower bound, that is I is equal to n minus 1. So we are going to substitute n minus 1 instead of I. So m of n is equal to 2n minus 1 m of n minus 1 plus 2 of n minus 1 2 power n minus 1 minus 1. So finally, after solving this equation, we get m of n is equal to 2 power n minus 1. So this is the final equation. So the analysis of the problems discussed. So we now discussed about we now discussed about the Tower of Hanoi problem. So size of the problem here is it is n. So basic operation is moving of one disk to another disk. The count of basic operation is big O of 2 power n minus 1 and the efficiency class is first.